Hello, welcome back to my channel. Welcome to the new school year. So today I'll be going over significant figures or sig figs. First I'll go over the rules and some examples on how to identify numerical values and how many sig figs there are, and going over the math rules and applying sig figs to that. So the four main rules of sig figs are already written here, and I'm going to go over each one and give you examples of each. So the first rule is that all non-zero digits are significant, meaning any numbers past 0, 1 through infinity. So for example, I'm going to do an example for each rule. So for example, if I have the number 52, these two digits are significant, so they have two sig figs. So that's the first rule. And that also can apply to, for example, 323. They're all non-zero digits, therefore there are 3 sig figs. All these digits are significant. So rule number 2 is zeros in between non-zero digits are significant, meaning that if they are sandwiched, I like to call it sandwich, in between non-zero digits, they are significant. So for example, if we have 5002, notice how these two zeros, so again, non-zero digits always significant, but then we look at the zeros. So going back, like significant figures are all about whether or not a zero is significant or not, and it determines whether a measurement is precise. So if we look at the numerical value 5002, these two zeros, since they're sandwiched, are in between two non-zero digits, they do count. So I have 1, 2, 3, 4 sig figs. Another example, let's say even if I have all these zeros in between, since they are sandwiched, they are all significant. So I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 sig figs. That is rule number 2. Alright, rule number 3 gets to do with leading zeros. So between the rules 3 and 4, it's very important that you understand the difference between leading versus ending zeros. Leading zeros are the zeros that are before non-zero digits. For example, if I have 0.00552, okay? So when you look at these zeros in the beginning, these are leading zeros. Leading zeros, they never, ever count. They are never significant. So we only start counting from the non-zero digit. So I have 5, 5, and 2. This example here would be 3 sig figs. Another example can be 0.0120 or 12. Let's just stop at 0.012. Alright, so again, these two zeros do not count, they are not significant, so only the 1 and the 2 are significant. So this example we had 2 sig figs. Alright, the last rule. So again, the leading zeros are the zeros that are before, the ending zeros are the zeros that are after, that are ending. So for example, the ending zeros are only significant with a decimal. So this is what confuses most students. So for example, if I give you 500.0, all these zeros that are after, since there's a decimal point, these are all significant. So I have 4 sig figs. However, if I get rid of that, I just written the same amount of digits, but I just removed that decimal point, these zeros don't count when there's not a decimal point. So I would only have 1 sig fig. So you've got to be careful there. Alright, so now I'm going to give you a variety of examples mixing these 4 rules together and you're going to apply them. So for example, if I give you 30,209, so there's zeros in between, so you basically have to apply rule number 2, that So we know, again, these non-zero digits are significant. I have 3, but then we have to look at, okay, these zeros, I know they are sandwiched in between non-zero digits, so they are significant. So I have 5 sig figs. If I give you another example, let's say 0.003200. So this is an example where you have leading and ending zeros, all right? So the leading zeros, again, never significant, but then you know that the 3 and the 2, they are significant, and then you look at, okay, I have these 2 zeros, my ending zeros, are they significant? You ask yourself, is there a decimal in the value? There is. Since there is a decimal point there, these also count. So my trick is I go through, so I know this does not count, this does not count, this does not count, the 3 does, the 2 does, and then look at these 2 zeros. Okay, I have this decimal here, so yes and yes. So in this example, I have 4 sig figs. Okay, now so I have the math rules when you apply, when you do calculations, and it all gets to do with rounding with sig figs, whether you add or subtract or multiply, divide, or doing both. All right, so when you add or subtract 2 or more different values, the rule is to round to the lowest decimal place, and I'll give you an example on that. And then when you multiply or divide, or even do both, you round to the least number of sig figs. So I'll give you an example for each of these. For the add and subtract, for example, if I give you just a simple addition, you don't even need to use a calculator, 5.0 plus 2.00 equals. All right, so we already know in our head that 5 plus 2 is 7, right? However, when you look at each of these values, again, it gets to do with accuracy and precision. So we know that the 5.0 is in its 10th place, so 1 decimal point, and then one decimal place, and then in the 2.00, it's in the hundredths place, so 2 decimal places. So I know this is the least or the lowest decimal place, so I would want to put 7 in 1 decimal place, or in the 10th place. That is the correct value how you would round. If I give you another example where you actually may have to use a calculator, like let's say 3.34 minus 1.223 equals. So when you just simply plug this into the calculator, simple subtraction, so I'm just going to write the full answer here. So 2.117, all right? That's exactly how I got it in the calculator. It's kind of hard to read there, but I get 2.117, but then you look at, okay, how do I round this? This is in its hundredths place, and this is 3 decimal places, so it's thousandths place. So since this is the lowest decimal place, I would want the 2.117 to be put into 2 decimal places, so 2.117. You look at the 2 decimal places, and then you have to look at the digit right after that. Do I have to round up or round down? So since this is 7, I know that I would have to round up to 2.12. Okay? Now, for multiply and divide, it's actually simpler because all you have to do is look at sig figs. For example, if I give you 3.0 times 5.53. Simple multiplication, 3 times 5.53. Again, I'm writing the full number here, as I see on my calculator, 16.59. And then you look at your values here. I know this is 2 sig figs, and then the 5.53 is 3 sig figs. Between these two values, the 2 sig figs is the least amount. So I would want to round this, the 16.59, to 2 sig figs. So 16.59, you would look at the first 2 sig figs, and again, you have to look at the next digit after and see how you would round that. So 16.5 and then 59, that would round up to 17. That would be 2 sig figs. I'll give you one more example where even when you divide, even when you do sig figs with a scientific notation. So this is more of a challenge question. Let's say I give you 5.32 times 10 to the power of 7 multiply by 2.1 times 10 to the power of 3. Alright, with scientific notation, there is no need to move decimal places and whatnot. Just plug it into the calculator, and your job and your responsibility is to figure out how to round to the correct number of sig figs. Alright, so you can calculate and then figure out sig figs, or figure out your sig figs and then calculate. So whatever works for you. So when I plug this in, 5.32 times 10 to the power of 7 times 2.1 times 10 to the power of 3. According to my calculator, I got 1.1172 times 10 to the power of 11. Alright, and when it comes to counting sig figs in scientific notation, the times 10 and the exponent, that never counts in sig fig rules. So looking back at the sig fig rules in the top of the page here, that there's no mention of scientific notation. So we are only looking at the normal numerical values. So this never counts as sig figs. Okay, so we know that the 5.32 is 3 sig figs, and then the 2.1 is 2 sig figs. Alright, so right now, if I'm looking at the final answer here, it's 1.1172, so that is 5 sig figs. So I would want to round that out to 2 sig figs. So 1.1 times 10 to the power of 11. Alright, so that concludes the significant figures and the math rules. I hope this helps, and I hope you have a wonderful day. Thanks for watching.